So today I'm going to explain this problem to you, and it's actually a popular algorithm called float fill algorithm, and it's used in editing applications like Photoshop and drawing apps like the Microsoft Paint app. And the idea is when you want to fill an area, a closed area of a certain shape with a certain color, you just press any point within this area and it will get filled with the same color. So um, um, we of course we are going to deal on the pixel level. Okay, so let's say we choose this pixel. Now we need to fill all the adjacent pixels with the same color of this pixel. Okay, so this is adjacent, this is adjacent, and after painting all those pixels with the same color, we still have this adjacent one. So basically any adjacent cell that has a common vertical or horizontal boundary with the pixel is going to be filled with the same color. But we are not going to fill it with one actually, rather we are going to use this color, which is given as a parameter here. So there's two ways of solving this problem: depth first search and breadth first search. So if we perform a breadth first search, we are going to start our first cycle by painting all the adjacent cells on a certain level, and on the second iteration we are going to perform the second layer of the same color. And for depth first search we are going to perform it in a depth manner. Okay, so it's a pretty standard depth first search algorithm. So first we are going to have the rows and the columns just to define our boundaries and not exceed the limit and get a out of bound value, out of bound error. Okay, so we are going to call it search, and it's going to take a row and column, and initially you are going to start from a certain given cell. Okay, so let's just get the color of it to search for it. So the target is the image of source row and source column as given, and check if we are eligible to color this cell. So first we check if we are in the boundary of the rows and for the columns as well. And in order to avoid infinite loops, you are going to have a visited set. Okay, just to keep track of already visited set cells so that we don't visit them twice. Okay, but here we are going to check the image of row and column. Is it equal to target? And of course, if the current row and column not unvisited, and if so, first we are going to mark it as visited. It's going to be a tuple, and we are going to color it with our given color, and after that we just visit adjacent cells both vertically and horizontally. Okay, so we are going to use directions array. This is common way of traversing 2D matrix. Okay, so just bear with me. -1, we are going to iterate for the direction row and direction column in directions, and just perform a search on the current row plus the direction column and the current column and direction column, so direction row I mean. Okay, so what this is doing actually is, let's say we are at this cell, we are going up, I mean down one row. Okay, so we are targeting this one here, and the up row, and the second column, the previous column. Okay, and of course if we exceeded the boundaries of the matrix, we are just going to do nothing and return immediately. So we are not entering this if condition, so we just return. Okay, finally we are going to call the function on the given source row and the source column, and we did it, we did the replacement on place, so we just return the original image. Okay, let's try that. I guess we are not missing any edge cases. Yeah. Okay, so it's a pretty standard depth first search algorithm. I encourage you to try it using breadth first search, just for the sake of practice. And thank you for watching.